So talk a little bit about the history of MIOX. We are a company that's about 14, 15 years old since incorporation, and the slide you see in front of you now is actually one of our earlier products, and I think it's a good example of the innovative culture of MIOX. This product was developed in coordination with the U.S. government through a DARPA grant, and the problem that was being solved was effective disinfection for military service, specifically special forces that would have to be deployed for extended periods with questionable water sources. And so some of the early research that MIOX did actually developed a very small portable tool, purifier device. As you can see on the picture here, it's about the size of a magic marker and runs on 2 batteries. But the most impressive part was that it actually achieved levels of disinfection of cryptosporidium, which was a very specific contaminant that's difficult to remove from surface waters, and was probably the most concerning for the special forces as far as getting waterborne illnesses. And so it's a good example of taking that innovative technology that was originally done and developed in the Los Alamos labs and producing it into a useful product for an end user. That technology then led into larger development of electrolytic cells. At the heart of the technology of that purifier pen was an electrolytic cell technology. Basic technology that you'll see more in the video. We'll start here in a minute, but it has a cathode and an anode. We run an electric current through a brine stream, and we're able to create a disinfectant chemistry, an oxidant chemistry, out of that electrolytic process. That's a relatively well understood process, and there's actually a number of companies in the industry that do that process and have that technology. Where MIOX is different, and where we feel we bring value to our partners and our customers, is the technology and innovation we've actually put into that electrolytic process. We're able to produce cells that have higher levels of reliability and longer life than anyone in the market. So we really feel that that's where we can bring value to the customers. So in the video, you saw that Joe walked through the Rio Zuni unit. That was the small stand-up unit. It's about the size of a water softener. And you could see the electrolytic cell on that unit slightly larger than Samsung iPhone type smartphone. Very compact, but has the same technology and history of innovation built into it. As you can see on the slide here, that unit produces about 1 pound per day of oxidant as product. So if you would equate that back to an application on a relatively typical dosage rate, the Zuni unit can treat up to 10,000 gallons of water a day. So it's not a product that's applicable for residential use, but certainly for small industrial applications. Some of the most common applications for the Rio Zuni unit are small cooling towers and small dairy farms, for example, is another application we're rolling out soon. We also have a number of customers that use them on small pools. And then you can see the technology scales very easily. In the video, you saw that Joe highlighted the electrolytic cell from the Vault and the Rio. Those are 2 mid-sized systems that we produce. The Vault system, depending on the output chemistry, whether it's a standard unit or a basic unit, produces 300 to 500 pounds a day, and then scales all the way up to the Rio Grande. But what's important to understand is that the technology inside the electrolytic cell is built on the same platform of innovation and history. Through MIOX's 12, 14 years of supplying thousands of systems to the market, we've learned extensively how to optimize the design of that electrolytic cell. And in fact, on this line that you're seeing on Zuni to the Rio Grande, we actually have two different electrolytic cell designs. One that's been optimized for low cost, and a second that's been optimized for the superior disinfection. And so I'll talk a little bit more of that in a minute on the next slide, but that's where we talk about our hypo and MIOX chemistries. One of the first questions we'll ask potential customers is the need for the product, the why question. What problem are we solving? Is it try to get a lower cost form of oxidant because of the location of the facility, for example, a mine in Peru where moving bulk sodium hypochlorite, even in a concentrated 12% form, is expensive because you're moving 80% water. So that would really be a driver for a low-cost solution. We have a number of other customers that use the technology as a replacement for some other biocide, or even a campaign of biocides. In those applications, we would recommend the mixed oxidant cell, which is the electrolytic cell that's been optimized for superior disinfection. So if you talk a little bit about some of the different attributes and benefits that we can bring to our customers and our partners, I've touched on two of them already. As I mentioned, cost is usually a driver for people to look at on-site generation technology. The cost of their oxidant delivered to site is expensive either for their location or potentially their climate. Bulk sodium hypochlorite, for example, breaks down in high temperatures, and so we have a lot of installed base throughout the southern U.S., Caribbean even, where storing bulk hypo breaks down over time, so you're actually losing your effective ingredient. Another benefit that we see customers looking for is that superior control of algae and microactivity. We have a number of customers that run cooling towers or distribution loops, whether it be a hot spring spa in Japan or a municipality in South Carolina. We have a number of proven case studies where customers were struggling with a biofilm buildup in their distribution system that was either causing disinfection byproduct issues, Legionella issues, or even just consumption of their oxidant. If you have too much biofilm buildup in a distribution system, all the money that the customer is paying to buy the oxidant to do the biologic control actually is wasted, or a good portion of it is, because it's absorbed and reacted with the biofilm in the system. We have a number of case studies where we've switched the chemistry to our optimized unit for superior bio removal, and within weeks, the customers see a dramatic 20-30% reduction in total usage of oxidant because they're no longer having to react to the biofilm. The biofilm had been stripped off. And then lastly, we wanted to touch on the reliability aspect. We get questions very often from our customers, from our installed base of, I use bulk bleach today. It's a tank and a pump. How does a MIOX system compare in user interaction, reliability, preventative maintenance requirements? And as Joe pointed out in the video, the systems are relatively simple. We need a source of brine, a source of water, and a source of electricity. And the system is relatively simple. After that, we simply run that brine solution through the electrolytic field, through the electrolytic cell, and on the outlet is an oxidant. And so as long as you have input and electricity, it's very easy to get the output. The key component in electrolytic technology is maintaining that electrolytic cell. That's really the key component for maintaining a long-term, reliable, and effective and maintenance-free system. And MIOX actually has some interesting technology built into our electrolytic cells that benefits that reliability. But in all cases, whether MIOX is the producer or another electrolytic company, the key to maintaining a system over time is keeping that electrolytic cell clean, preventing any scale formation on the electrolytic cell. And so really that self-cleaning and design of the electrolytic coatings to prevent and limit scale form up is a key to the reliability of the systems. We also have a number of customers that see a secondary benefit besides the cost and the performance issue, which is usually the driver. We do also represent an environmental footprint benefit. If you look at the amount of trucking required for a facility to bring in the raw salt to make the brine, as opposed to bring in either one or multiple chemicals that are usually, even at their highest concentration, only 20 or 30%, the amount of water that needs to be moved is dramatically reduced. And so this is where we potentially see on many of our applications a reduction up to 80% of carbon footprint if measured by the transportation of the facilities.